Welcome to the online lectures for software engineering. In today's class, we'll be focusing or we'll be studying the model Unified Process Model, the UP model. Now, this Unified Process Model, it was developed by three persons, namely Jacobson, Rumbach, and Booch. Three persons have designed this particular model. Now, these three persons have designed this particular model because, according to them, our appetite for sophisticated software is growing day by day. Every time a software is being released, we are going to focus on how we want to improve the particular software. So we want a particular software that is going to focus on how well the customer understands the software or how better it is adapted to a customer needs. For that purpose, the unified process model came into existence. Now, this describes the customer's view of a particular system. You can say that what are the needs for the particular end user, those are very well defined within the unified process model. Now, this unified process model, it combines the best features of the other conventional model. Best features, and here we have studied different models: waterfall model, spiral model, component based development model. It is going to take many of the features of these models and it has formed one model that focuses on the customer needs. Now, this unified process model, it uses UML for documentation and design. Now, what does UML stand for? Now, UML stands for Unified Modeling Language. Oh, UML stands for Unified Modeling Language. Now, this Unified Modeling Language, it is basically used for different types of diagrams. For drawing these different types of diagrams, you're using this UML diagram. For documentation as well as for the designing of all the software, you're going to focus on the UML language. Now, within the previous class, we have studied that there are different UML diagrams. There are 9 diagrams that you're going to study within the lab for software engineering. So 9 diagrams. By making use of these 9 different diagrams, you're going to document, that is, you're going to provide a SRS, documentation as SRS, and you're going to make the design, that is, the architecture will be represented by making use of this UML representation. Now, coming on to the key features for unified process model. Now, the first feature is the process flow is iterative and incremental. Now, iterative and here means it is going to repeat a few number of steps to complete a particular task, that is iterative. Whereas what is incremental? Incremental means when you are going to deliver the basic software, and then on it you're going to keep on adding the increments. You're going to keep on adding increments, that is, you're going to keep on delivering the increments. If you remember the previous example that we have studied within the incremental process model, if you're using the Microsoft Word, if you're using Microsoft Word, or you've told the end users that you want a software to be developed that is going to document the features, that is going to be used for documentation, adding pictures, it should have dictionary features, all of them you have mentioned. But in here, within the first basic delivery, you're just going to deliver the basic document editing feature. Within the later increments, you can add the dictionary purpose for auto correction dictionary. You can add the different page layout options are added, that is incremental. So this unified process model, it follows a process flow that is iterative as well as incremental. The next key feature is risk focus. Now, risk focus in here means you're going to identify how many risks can arise within the particular software. Now, when you identify that some specific risks are going to occur, then you can focus on how to eliminate these risks. The next one is use case driven. Now, this is a use case. This is one of the UML diagram. This focuses on behavior of a particular system. behavior of a particular system. Now in detail we'll be studying this use case diagram. It describes the operation of a software as interactions between the customer and the system. Now in here, this stickman in here, this is called as your primary actor. This is called as actor. Now the first main actor is called as primary actor, whereas the second actor in here is the actor that the primary actor is making use, so that the task that primary actor is doing, that should be fulfilled. This actor is called as secondary actor. So the primary actor makes use of the secondary actor to fulfill a particular task. Now in here, the primary actor is a account holder. Now these oval boxes in here, these oval boxes are called as use case. This rectangular boundary in here, this rectangular boundary, it can be called as boundary or environment. Now for this particular example, this is a example for ATM systems. So you got the primary actor. This primary actor, he needs to enter the pin to withdraw the money. Now when he is entering the pin, this pin is verified by the bank server. That is, the primary actor is making use of the secondary actor to fulfill a particular task. Then to withdraw the funds, again, if suppose the account holder, after entering the pin, he wants to withdraw the funds, when you withdraw the funds, the amount needs to be deducted from the bank server, and that needs to be updated. Now if suppose you are withdrawing the money and it is not updated within your account, so it is going to be a problem. You're just going to think that your account has the exact amount of balance that you had before withdrawing. So it is necessary that this change gets reflected within your account. Then if you are depositing funds, then these depositing funds also need to be updated within the account. Even if you're transferring funds, all options need to be updated within your account. That is, these changes need to be reflected in the account. Even when you're checking balance, this requires the bank server, because this balance is, your request will be fetched from the bank server. The bank server is going to tell you how much amount of rupees are available within your bank. So this is a use case diagram. This use case diagram, it describes the interaction between the customer and the system. Now this is the system that you are developing, the ATM system. Whereas the primary and secondary actor, these are the two people that are responsible for completing a particular task. So this unified process model, it is a use case driven model. The first we have studied is it was iterative and incremental, second is risk focused, and the third one is use case driven. Coming on to the third one is architecture centric. Now in here, architecture centric means in here you're going to design an architecture for the software that you're developing. You're going to design an architecture. Now within this architecture, what are the different things that it is going to take into account? Now in here, you're going to identify the different technologies that you're going to use, the latest ones. The programming language, it can be Java, it can be C, it can be C#, it can be C++, what type of programming language. An operating system, what is the operating supports you're given, that will be identified. Then development and release environment, that is at what environment you're developing the particular software. First, suppose you want a particular software that needs to be adaptable on different operating systems, suppose Windows and Linux. So you're first developing it in Windows and you're releasing it also in Windows. Later you can also add this is also supported in the Linux versions or the Unix version. Then what are the different server capabilities that are provided? Within the architecture diagram, you're going to have all of these things. Now the use case and the architecture, system architecture, these both are related. How they are related? Now this use case, it drives the system architecture. That use case, if you have the use case diagram, it becomes easy to design the system architecture. Whereas this system architecture, it influences the use case diagram. You can say that both are directly related or directly associated. So these are the four key features of the unified process model. Coming on to the phases of unified process model. There are four main phases of unified process model. The first one, inception. Second, elaboration. third construction and transition phase. Now coming on to the diagram, this is how your unified process model is going to look like. Now in here you can see that you have got the different phases, like you've got the communication phase, that these phases are in which order? The waterfall model, C, P, M, C and D. Communication, planning, modeling, construction and deployment. These are the four different phases. Now in here you're going to make use of these phases and you're going to make four phases out of it. That is, you're going to do is communication and planning is combined and it gives rise to the inception phase. Then the planning and modeling in here, by adding these two you get the elaboration phase. Then there is nothing common between the construction phase. Alone construction phases construction, and then when you add deployment and the construction phase you get the transition phase. So this is how you need to draw the diagram. All five phases of waterfall model. Combine the first phase you'll get, combine the second and third, you're going to get the second phase. Then only construction, this is your third phase. Then combining construction and deployment, this is going to be the fourth phase. There are four phases. Now at the end of this transition phase you're going to have a fully workable software. So the last phase will be the production phase. The production phase is the extra phase after the software is being developed. Now coming on to the first phase, the inception phase. Now within the inception phase, as we know that this inception phase, it is combination of the communication and the planning phase. It is a combination of communication plus planning phase. Now we very well know what happens in communication. Within communication, you're going to gather all the set of requirements that the user wants within the operating system or within the software that is being developed. Within the planning phase, what do? You make a particular schedule. You identify the different risks that are going to be there within that might occur within the software, and you're also going to identify what are the different resources that will be required for the development of this particular project. So these are the tasks that are going to be performed within the inception phase. This is the combination of the two tasks. Now by doing this you identify what is the scope of the project, why we are developing this project, that will be identified. Now as this is the first phase, that is the inception phase, you're going to have the fundamental requirements. Now what is fundamental requirements? Fundamental requirements, you can say that fundamental requirements are basic requirements that are need to be there within the software. For these fundamental requirements, you're going to design a preliminary use case. Now preliminary means a basic version. You're going to design a basic version of the use case diagram. The use case diagram that you've seen within the previous slides, you're going to make a very basic version. That is not the exact one, but a preliminary, a basic one. A basic use case is used to represent the fundamental requirements. Whereas to understand those requirements, you also have a set of business requirements. Those business requirements will be developed by making a rough architecture diagram. Then as this is a combination of planning phase, you're going to identify a project plan. That is how you're going to develop the different components, what is going to be the schedule, how much time is required. And as I told you, this particular key feature of this particular unified process model is risk driven. You are going to continuously analyze the risk. You're going to continuously identify the risk within the inception phase. The next phase is an elaboration phase. Now this elaboration phase, it is combination of planning phase and the modeling phase from the waterfall model. Now in here within the previous phase we have designed a preliminary use case. Now this preliminary use case is going to be expanded. Now why we are expanding this preliminary use cases? These preliminary use cases are expanded so that you get to know what are the functional requirements, and second one, what are the non-functional requirements. You're going to identify these both set of requirements by expanding the use case diagram. Now the functional requirements, they are going to tell you what the system needs to do, and non-functional requirements are not going to affect the functional requirements. That can be like performance, accuracy, maintainability. Now again, It is a continuous risk management process. Now, within this elaboration phase, you're going to develop an architecture. Now, within the first phase, we have only developed the use case diagram. Now, this use case diagram, you're going to, after this use case diagram, you're going to design a entire architecture. Now, this entire architecture is going to be designed by having 5 different views. These 5 different views are going to be the use case view, second is analysis, third design, implementation and deployment model. You're going to create these 5 models within the elaboration phase. Now, the use case diagram is going to tell you the behavior of the system. Analysis model, you're going to map all the requirements that were told by the end user to the requirements that were stated. That is what you're designing and what was stated by the end user, whether all of them are present or not. Designing means you're going to make an architecture. Implementation will require coding part. Implementation is the coding. Then deployment is delivery of the software. Now, if you want any modifications to be there within the software, this modifications can be done in this phase. Modifications can be done at the elaboration phase. Accepts modification at this level. Then you're going to make a plan for construction. You're going to be a one step ahead. You're going to make a plan for this construction. Going on to the third phase, that is the construction phase. Now the construction phase is only the construction phase of the waterfall model. Now within the previous slide, we have seen that we have designed the analysis and the design model. We have designed these 2 models, analysis and design. Whereas what you're going to do within the construction phase, you're going to make use of this analysis and design model so that you make the complete version of the particular software. That is what you're doing in here is you are going to expand the analysis and design view that was there in the elaboration phase. That is there in elaboration phase. You're going to define that so that the entire complete version of the software can be developed. Now this construction phase, within the construction phase, what are the different features that were told by the end user and the different functions that you need to be implemented that are going to be added within the source code. That is, the coding is going to be done in here. Then the next part is unit tests are designed. Now this unified process model in here, within the unified process model, this adapts a technique for component reuse. You can make use of different components and then you can assemble each of them and you can develop the entire software. Now unit means one. So in here what you're going to do is you are going to test each component individually. You're going to test each component. Then after that you're going to do the integration testing. Now after testing each of the component individually, you're going to integrate, you're going to put all of this together, you're going to add all of the components together, and then you're going to check for any types of errors. Now if suppose there is no error in the unit testing, there might be an error within integration testing. When you combine different components, you might have an error, so you're going to check for those errors. If errors arises, you're going to try and remove the errors. Whereas you're also going to perform as acceptance testing. Now this acceptance testing is very important because this acceptance testing is going to check that the model that you have developed, whether it is satisfied by the user criteria. Whether the user criteria is satisfied or not, that is going to be identified in here. The user requirements that was stated by the end user, whether all of them are satisfied or not, that will be identified within the acceptance testing. The next phase is the transition phase. Now this transition phase, it is combination of construction plus the deployment phase. Now within this the testing, now this first testing, that is the unit testing, integration testing and acceptance testing. This testing is done by the developer. This testing is done by the developer. Now this type of testing, it is also called as alpha testing. unit testing, integration, acceptance testing. The testing that is done by the developer, they are called as alpha testing. Within the transition phase, you're going to perform is beta testing. Now this beta testing, it will be done by the client. The client is going to identify whether the following functions and features that you have embedded within the software, whether that is the same that was stated in the requirement gathering phase. Now if suppose they find any type of discrepancies, any corrections need to be there, those corrections will be made and your software will be improved within the transition phase. Now at this phase, you're also going to train the customer person, because the software that you're developing, it might have different set of features and different set of entire different user interface. So you need to train, a training session will be given for for the customers. Then the customers are going to be trained at this level. And you're also going to add support information. Now support information in here, it is, you can have different types of user manuals, any troubleshooting guides, and installation guides. That is how you're going to install the software, that will be identified. User manual, how you need to, what is each and every function, how you're going to operate. If any error occurs, how you're going to resolve the particular error, that is troubleshooting guides. These are the support information that will be developed at the transition phase. Then at the end of this transition phase, you are going to have a software that is a usable software, that is, you can operate on this particular software, you can operate, you can use this particular software. This becomes a usable product. The last phase is the production phase. Now there are four main phases that are used for designing the software, whereas the production phase, you are going to deliver this entire software to the end user. This software is being delivered. Now this is not at the end user side. This software is delivered. So in here, the ongoing users monitor, that is when you give any type of real-time problem, how this is functioning in a real-time world, that will be identified. Now as you know how this is working in the real time, if any defects are there or any deficiencies are there, that some changes need to be there for a specific function, this is not working properly, these deficiencies will be reported to the developer, and the developer is going to make those changes, or he is going to provide support. That is how you need to tackle the particular problem. You can have this support team that will be provided. That is the production phase. We've completed the 5 phases of the unified process model. Now there are different work products that are delivered at the end of the 4 different phases. Now within the inception phase, you've got the vision document. That is, at the inception phase, when you gather all the requirements and you make a plan, you get to know what is the goal of the particular software, why you're developing this software, that will be identified. Then initial use case, that is the preliminary use cases will be defined, the basic ones. Then initial business case, this is the how you're going to understand the requirements, how you're going to understand this requirement, that is identified. Initial risk list, what are the different risks that might occur. Then you're going to make a project plan based upon the days or weeks. You're going to identify this. Prototype means a basic version, a model. A prototype is a model. You have got a basic model because you have made a use case diagram and you have also made a rough architecture diagram. Now this use case diagram is for fundamental requirements, and architecture, this is for business requirements. Whereas within the elaboration phase, you're going to elaborate this initial use case model. This model that was developed in here, you're going to expand this model. Then you have an analysis model, that is the 5 different views. 5 views are added. Then you're going to revise the risk list, and the manuals, preliminary manuals will be added. That is how you're going to troubleshoot a particular risk, that will be identified in here. Then within the construction phase, you have the design model, the different components that you will be using, a testing plan. That is how you're going to test the different components. And what will be the procedure for testing? The different test cases will be identified, and then these preliminary manuals that you have developed thus will be expanded as installation guides, troubleshooting guides, and different support material. Then the last phase is the transition phase. Now within this transition phase, you're going to have a software increment. That is, when the software is being developed, beta testing is done by the client. Now, when the client works on this, you're going to give the feedback, whether any changes need to be there or not, that will be identified. Based on that, you can make any changes within the software. So these are the four main phases of the unified process model, and this particular answer is important for 7 marks. If you have only, if you need to explain only the phases for unified process model, if this comes for 10 marks, then you need to define the different work products. Also, you need to define the 4 different diagrams, the 4 different work products. Work products are nothing but, you can say that these are kind of report or document that is generated.